All right, let's do some homework problems. So we're going to start with number 12, which wants us to graph two full periods of each function and state the amplitude, period, and midline. State the maximum minimums and their corresponding x values on one period for x. All right, there's a lot of things. So number 12 is 2 sine of 1/2 x. Let's graph it at the end. Let's do everything else first. State the amplitude, period, and midline. Amplitude, period, midline. Let's do that. Amplitude is the absolute value of this a. Amplitude is 2. There's an x right there. Period, right? Period is 2 pi divided by the absolute value of b. It's going to be 2 pi divided by 1/2, which is the same as multiplying by 2. Our period is 4 pi. And the midline has to do with d. There is no d. The midline will be the line y equals 0. You need this y equals part. The midline is the equation of a horizontal line. All right, so that's the first part. Amplitude, period, midline. State the maximum and minimum y values and their corresponding x values on one period. So that's probably kind of easier to do after we get a graph. So let's get our graph in here. The midline is at y equals 0. It's that x-axis, so we don't need to necessarily draw it. It's sine. We're starting at 0. We're starting in our middle. Let's graph it with Desmos. Sine of 1/2 x. I don't remember this function. 2 sine of 1/2 x. So the period, right? The period is 4 pi. So when we're drawing our scale, we should draw it in terms of pi's. Again, a very kind of easy way to do is just count 4 boxes and have that be your period. That's 4 pi. This is 2 pi. This is negative 2 pi. This is negative 4 pi. And the amplitude is 2, so we have to go up to a maximum of 2 and a minimum of negative 2 right here. All right, well, we're starting at 0, 0. And then we have a maximum at pi, comma 2. Back to the midline at 2 pi, comma 0. Minimum at 3 pi, negative 2. And then back to the midline at 4 pi, comma 0. We just keep oscillating like this in both directions. Once you have these points, connect them with a wave. And now let's answer these other questions. So we also need to include the information, the maximum and minimum y values. This is part of our answer. The maximum minimum y values is 2. The minimum is negative 2. Right? The highest we ever get is a y value of positive 2. The lowest we ever get is a y value of negative 2. And their corresponding x values for one period. So one period for x is positive. So for that, for these corresponding x values, one period, x is positive. We're going to look at this region right here. This is one period of the graph for positive x. So in this graph, where are these maximum and minimums attained? And the answer, and actually let's keep that up. I kind of like that. This is one period. Did I have that wrong before? This is one period right here. Where do the maxima and minima occur? Here's a max, that's at pi. Here's a minimum, that's at 3 pi. So maximum is at pi and minimum is at 3 pi respectively. Respectively just means the first one goes with the first one, the second one goes with the second one. What else do we need? Round answers to 2 decimal places if necessary. Nope, we're good. Those are the 3 things this problem asked us to do. We're good to go. Let's do another problem. Let's do number 20. Number 20 says graph 1 full period starting at x equals 0. So here we only want to graph 1 period starting at x equals 0. And then state the amplitude, period, and midline. That's like before. And then there might be a phase shift in vertical translation. Okay, so it wants, here, let's write down the function. For 20 is 4 cosine of 2 times t plus pi over 4 minus 3. All right, and it wants the amplitude, period, the midline, the max and minimum values, phase shift, vertical translation. So a lot of things we need to include here, and a graph. Whew. Okay, let's do it one at a time. So to start, you have 2 options. Remember I said there are 2 forms for cosine and sine? One is this form, where this is our b value. This is our b value, and this over here was our c over b value. So this is actually already in a really nice form. You could distribute that too as well and simplify and get it in the form that we usually use, but this is actually a bit of a nicer form actually. It's your choice. Again, amplitude has to do with this. Vertical shift has to do with this. Let's fill things in. Amplitude, that is 4. It's the absolute value of A. Period. Well, normally it's 2 pi, but we're going twice as fast. The period is 2 pi divided by the amplitude of B, the magnitude of B. 2 pi divided by 2 is just pi. The midline is the line y equals -3, which is very close to the vertical translation. Vertical translation says we're going down 3. The maximum, let's worry about that in a bit. The phase shift, though, we do know. Phase shift is c over b. So it's going to be pi over 4. But there's a plus sign when it's usually a minus sign. So it's actually going to be to the left instead of the right. Let's get the maximum and minimum after we draw the graph. So we're going to start by drawing the midline. The midline is going to be at -3. You know what? I'm going to nip this in the bud. We're going to be way down here. I don't want to draw behind my head. There wasn't really a problem with the graph. It just would be hard for you guys to see it. So the midline's at -3. Right, this is at -3. That means we're counting by ones. And then the amplitude is 4. So we're eventually going to go up to +1 and down to 1 and down to -7. That's the minimum and maximum values. 1 and -7. All right. And do we need to say when these maximas happen? Yeah. Oh, and it only wants us, right? Graph 1 full period starting at x equals 0. Let's be very careful to do that. Let's write this function down. This y equals 4 times the sine, sorry, just kidding, 4 times the cosine of 2 times t plus pi over 4 minus 3. So we only want 1 period starting from 0. Let's start at 0. 1 period is pi. So this is the only part of the graph that we care about. And y is going from -7 to +1. This is all it wants us to graph here. Look at the instructions, right? Graph one full period starting at x equals 0. So we're starting right here at 0, -3. One full period is a single pi. So let's count 4 squares and say that's our full period, pi. Well, then we start at the middle. At pi over 4, we're at -7. So a quarter pi over 4 is right here. And then at pi over 2, we're at the middle again. At 3 pi over 4, we're at the maximum of 1. And then at pi, we're back to the middle. It only wants one period. So we're only graphing this much. So the maximum is 1, and that occurs at 3 pi over 4. The minimum is -7, and that occurs at +pi over 4. And that's what they want you to do for these problems. Let me know if you have any questions, because this one specifically is a little bit different than what we've been doing. Let's do 28 next. So if you look at 28, determine the amplitude, period, midline, and an equation involving sine. So I'll turn off my graph paper. We need the amplitude, period, and the midline for this graph that's involving sine. So the midline is the middle. It starts at 0. 0 is the middle. That's our midline right there. Y equals 0. The period, well, it takes 1 to get here. It takes 2 to get back to where we started. If you look the other way, it takes 2 to get back to where we started that way too. So the period is 2. And the amplitude is, oh no, not again. And the amplitude is what happens. It's how far do we go from the midline to get to the maximum or the minimum. So we go 2 up to get to the max, or 2 down to get to the minimum. The distance between the minimum and the maximum is 4. So half that distance is our amplitude. Our amplitude is also 2. So it wants us to use sine. So we're going to have y equals a times sine of bx minus c plus d. We know a is 2. There's no negative because we're going up. Sine of b, we don't know b, right? The period is 2, but the period is 2 pi divided by the absolute value of b. And we can assume b is positive here. So the period is 2. That equals 2 pi divided by b. Cross multiply. Right, 2 is 2 divided by 1. And we're going to get 2b equals 2 pi, or b equals pi. So we get the sine of pi x, there's no phase shift, plus d, which is 0. This should be our equation. Well, let's graph it. Is y equals 2 times the sine of pi x look like the same graph? Put a step size of 1 and look from -2 to +2 so that it has the same scale. Do these look like the same graph? Yes. Yes, they do. That's number 28. Let's do one more over here. Let's do number, oh, it's when I highlight something, I think, that, whoa, that causes a problem. Let's look at 36. I don't know where I am anymore. Having serious issues here. Number 36. Let f of x equal sine x. Right? It says that up here. On 0 to 2 pi, the minimum occurs at what value? So you can just graph this if you want, or you can do it by hand. But if you graph it, you just graph sine of x and say, okay, we only care about the interval from 0. And again, look at what I'm doing here. Click on this graph settings, this wrench, 0. We only care about 0 to 2 pi. And it's asking, where is the minimum? Well, we can make our step size in terms of pi to make things a little bit more clear. The minimum occurs when x is 3 pi over 2. Right there, that's the minimum, when x is 3 pi over 2. And that's our answer. All right, let me know if you have any questions. Best of luck. Have a great day, morning, night, whatever.